Learn like a pro.
Have you ever wished you could teleport? Just move from one place to another instantly? Well, what if I told you we can kinda do that with solid metal? Today, we're diving into a process that does almost that, the Great Copper Shuffle. We're gonna see how you can move metal atom by atom without ever melting it down.
So here's the puzzle, right? How in the world do you take a piece of solid copper and just move its atoms over to another piece of copper, especially with no furnace in sight? Well, the secret lies in a fascinating little journey powered by electricity. That flow of electrons is what gives us the energy to pull atoms apart and then piece them back together somewhere else.
And we do it by sending its atoms on this wild ride. To really get what's happening, let's just follow one of them. Everybody, meet Chip. He's a single, humble copper atom who's about to have a very big day. He's going to leave his home, travel through a strange new world, and find a new place to live, all thanks to a little electrical nudge.
Okay, so first things first, let's set the scene for Chip's big trip. I want you to picture not a boring old lab, but a bustling ion marketplace. It's basically an electrical circuit dunked in a special solution where atoms are literally bought and sold.
Now, the real stars of this show are what we call reactive electrodes. See, unlike your typical electrodes that are just there to conduct electricity, these guys, in our case, 2 pieces of copper, they get right into the action. They are active, willing participants in the chemical reaction itself.
So in our marketplace, you've got 2 main players. First, there's the anode. Think of this as the seller's stall. This is where atoms get sold off into the solution through a process called oxidation. And on the other side, you've got the cathode. That's the buyer's counter, where atoms are bought out of the solution through a process called reduction. Seller and buyer. Simple, right?
All right, we know the layout of our marketplace. Now, let's actually follow our little atom, Chip, on his electric adventure from the seller to the buyer. So here's the game plan for Chip. He starts out as a happy solid atom hanging out at the anode. Then, zap, he loses 2 electrons, which totally transforms him into an ion, and he floats off into the solution. He then drifts across this liquid marketplace over to the cathode. Once he gets there, he gets his 2 electrons back, and poof, he's a solid copper atom again, just in a brand new spot. Let's zoom in on that first step. Over at the anode, Chip has to pay a toll to even enter the marketplace. That toll? 2 of his electrons. This whole process is called oxidation, and it's what turns Chip from a solid neutral atom into a positively charged copper ion, which lets him dissolve and start his journey.
And here's the thing. Chip is not alone, not by a long shot. As millions upon millions of his copper buddies do the exact same thing, the anode, our seller's stall, is literally selling off its inventory. You can actually watch it get smaller and smaller over time.
So after his swim across the marketplace, Chip finally arrives at the cathode, the buyer's counter, and waiting there for him are 2 electrons. He snags them in a process we call reduction, and that transaction turns him right back into a solid neutral copper atom. And just like that, he settles into his new home on the surface of the cathode. And just as the anode shrinks, the cathode does the opposite. It grows. As millions of chips finish their journey and settle down, it's like a brand new neighborhood is being built, one atom at a time. The cathode's mass actually increases, and you can see it get visibly thicker.
Okay, but wait a second. This brings up a really good question. That distinct blue color of the copper sulfate solution, that comes from the copper ions floating around. So if ions are constantly leaving the solution to stick to the cathode, shouldn't the blue color start to fade out?
And the answer is no, which is so cool. It's because our little marketplace is perfectly balanced. The rate of selling is the exact same as the rate of buying. For every single copper ion like Chip that leaves the solution at the cathode, a brand new one dissolves from the anode to take its place. The inventory of ions in the solution stays perfectly constant, so the blue color never changes.
So this whole atom shuffling thing isn't just some neat chemistry party trick, right? This is the actual foundation for some huge industrial processes that we totally rely on every single day.
The 2 biggest applications are electroplating and metal purification. Electroplating is all about coating something with a super thin layer of metal, either to make it look good or to protect it. And metal purification uses the same idea to pull out pure metal from a chunk of impure junk.
Let's make this super real. Say you want a copper plate of spoon. Easy. You just set up your marketplace with the spoon as the cathode, the buyer. The anode, the seller, would be a bar of pure copper. You flip on the power, and boom, copper atoms start their journey from the bar and lay themselves down in a perfect, shiny new layer all over your spoon. And yeah, making things shiny is nice, but the real industrial superpower here is protection. That thin layer of metal acts like a suit of armor, preventing the object underneath from rusting and corroding away. It's a huge deal.
The other major application is purification. Now, imagine your anode is a block of impure copper, all mixed up with other gunk. Well, in our electrolyte marketplace, only the copper atoms are interested in making the trip. They dissolve, travel over to a pure copper cathode, and plate onto it, leaving all those impurities behind as useless sludge. It's like an exclusive first-class travel service just for copper atoms.
All right, let's step back for a second and put all these pieces together. Let's look at the big picture of this great copper shuffle.
So after all that dissolving and plating and traveling, what's the grand chemical finale? What's the net change? Get this, absolutely nothing. The chemical equation for what's happening at the anode is the exact perfect reverse of what's happening at the cathode. They completely cancel each other out. All we've really done is move solid copper from point A to point B.
Okay, quick pop quiz. Let's see who is paying attention. Thinking back to our marketplace, what happens to the mass of the anode, the seller's stall? That's right, it decreases. It has to, right? Because it's constantly selling its atoms into the solution.
And what about the name of that process? The one happening at the anode, where Chip loses his electrons? That's called oxidation. Quick tip to remember it. Anode and oxidation both start with vowels, A and O. Cathode and reduction both start with consonants, C and R.
And that really brings us to our final and I think most fascinating question. If this is all just a relocation service for atoms, why is it one of the absolute cornerstones of modern industry? Because that simple, elegant act of moving metal, one atom at a time, is precisely what protects our cars from rust, purifies the copper wiring inside our phones, and so much more. It's a powerful reminder that sometimes the biggest industrial revolutions happen at the smallest possible scale. Thanks for joining the Shuffle.